Hello viewers, in today's session we are going to discuss another conceptual problem from derivatives, and here we are going to solve this problem where we are given a function y that is equal to sine inverse 1 minus x square over 1 plus x square, where x belongs to the interval that is the open interval 0 comma 1, and we have to find the derivative of y with respect to x at x is equal to 1 over square root of 2, right? So let us see how we can find out the derivative of this function y at this point using the concept of inverse trigonometric functions. So let us start. So here the first step is to make this substitution, that is x is equal to say tan theta. So we are making this substitution because we know that 1 minus tan square theta divided by 1 plus tan square theta is given by cosine 2 theta. So the double angle formula for cosine function, that is cos 2 theta, is given by 1 minus tan square theta over 1 plus tan square theta. So when we take x is equal to tan theta here, this function y, it takes the form y is equal to sine inverse 1 minus tan square theta divided by 1 plus tan square theta, and this expression can be replaced by cosine 2 theta. So we have now sine inverse and cosine 2 theta. So now this is an important expression, right? And here we are given this condition, that is x belongs to the interval 0 comma 1, that is x is greater than 0 but less than 1. So now to move further, let us make use of an important property of inverse trigonometric functions, that is the sine inverse of say sine alpha is equal to alpha, provided this alpha belongs to this interval, that is minus pi by 2 to pi by 2, right? So here we have minus pi by 2, and here we have pi by 2, and if we take the value of the approximate value of pi, then minus pi by 2 is approximately minus 1.57, and here we have plus 1.57. So sine inverse of sine alpha is equal to alpha, where alpha belongs to this interval, and here this expression is similar to this one, but here we have cosine 2 theta and here we have sine alpha, right? So the first step is to convert this cosine function into a sine function, right? So here we'll make use of an important identity from trigonometry, that is sine pi by 2 minus x is equal to cosine x, right? So now we can write y is equal to sine inverse, and here we have cos of 2 theta. So cos of 2 theta can be written as sine, and here we have pi by 2 minus 2 theta. So here we have taken 2 theta for x, right? So sine pi by 2 minus x is equal to cosine x, so that sine pi by 2 minus 2 theta is equal to cosine 2 theta. So replacing cosine 2 theta by sine pi by 2 minus 2 theta. So now here we have the sine function. Now the value of alpha is given by this expression, that is pi by 2 minus 2 theta. So now the value of alpha, that is pi by 2 minus 2 theta, must belong to this interval, that is minus pi by 2 to pi by 2, because then only we can write here sine inverse of sine pi by 2 minus 2 theta as pi by 2 minus 2 theta, because we can write this expression as sine inverse, and here we have sine alpha, right? And sine inverse sine alpha is equal to that is alpha when this alpha, that is pi by 2 minus 2 theta, belongs to this interval. So let us first verify that this alpha, that is pi by 2 minus 2 theta, is it lies in this interval. So we'll make use of this inequality, that is the given condition. So here we are given that x is greater than 0 but less than 1. Now x is tan of theta, so we can now write here tan theta, and here we have 1, right? So now when tan theta is greater than 0 but less than 1, then theta belongs to the interval, that is 0 to pi by 4. So taking the tan inverse of these three quantities, here we have 0, and then here we have simply theta, and tan inverse of 1 is pi by 4. So when tangent theta lies between 0 and 1, then theta lies between 0 and pi by 4. So now here we have 2 theta. So let us multiply this inequality throughout by 2. So here we have 0, here we have 2 theta, and here we have pi by 2. So here cancelling this 4 by 2. So now we have 2 theta, it belongs to this interval 0 to pi by 2. So now here we have a negative of 2 theta. So let us multiply throughout this inequality by minus 1. So here we have 0, here we have minus 2 theta, and here we have minus pi by 2. And when we multiply an inequality by a negative number, the direction of the inequality gets reversed, right? So now we have this inequality, which can also be written as minus pi by 2 is less than minus 2 theta. This is further less than 0. So now here we have pi by 2 minus 2 theta. So let us add pi by 2 throughout this inequality. So we have now here pi by 2, and here we have minus pi by 2. So adding pi by 2 throughout, we have here pi by 2 minus 2 theta, and then we have 0 plus pi by 2. So here these two terms get cancelled. So we have 0. Here we have pi by 2 minus 2 theta, and here we have 0 plus pi by 2, that is pi by 2. So we have now pi by 2 minus 2 theta is alpha. So here we have pi by 2. So now alpha lies in the interval, that is 0 to pi by 2. So here we have 0 in between minus pi by 2 and pi by 2. And from this inequality, we see that alpha belongs to this interval, that is 0 to pi by 2, right? And it is verified that alpha belongs to this interval. So we have seen that pi by 2 minus 2 theta, that is our alpha, it belongs to this interval, that is minus pi by 2 to pi by 2, and 0 to pi by 2 is a subset of this interval, right? So we have verified that this expression pi by 2 minus 2 theta belongs to this interval. So now we can write sine inverse of sine pi by 2 minus 2 theta as pi by 2 minus 2 theta due to this property. So now from this expression x is equal to tan theta, we can write theta is equal to tan inverse of x. So substituting for theta as tan inverse x, we have y is equal to pi by 2 minus tan inverse x, and here we have 2. So now we can differentiate both sides with respect to x. So dy over dx is equal to the derivative of pi by 2 is 0, being a constant, and here the derivative of tan inverse x is 1 over 1 plus x square. So this is minus 2 over 1 plus x square. So the derivative dy over dx of this function is equal to minus 2 divided by 1 plus x square, and here we have used this result, that is the derivative of tan inverse x is 1 over 1 plus x square. So now we have to find the derivative at this point. So let us substitute x is equal to 1 over root 2 in this expression. So we have minus 2, 1 plus 1 over root 2 square. So we have minus 2 over 1 plus half. Root 2 times root 2 is 2. So we can now have here minus 2 and 1 plus 3, 1 plus half is 3 over 2. So we have here minus 4 over 3. So they taking this 2 to the numerator. So we have minus 4 over 3. So the value of dy over dx at x is equal to 1 over root 2 is given by minus 4 over 3. Hello viewers, in today's session we are going to discuss an important problem from inverse trigonometric functions, and here we have to find the value of this expression, that is sine inverse, and here we have cosine 39 pi over 5, right? So we'll see how we can find out the value of this expression using the principal value branch of inverse sine function, right? So let us start. So whenever we have to find out the values of expressions of this type, where we have here sine inverse function, and then we have say here we have the cosine function, and here we have some angle, right? So to find out the value of these type of expressions, we usually make use of this property of sine inverse function, that is sine inverse of sine theta is equal to theta, provided this theta it belongs to the interval that is minus pi by 2 to pi by 2, right? So here we'll make use of this property to find out the value of this expression. So now if we compare this expression with this one, then we can easily observe that here we have a sine inverse function, here also we have the sine inverse function, and inside this sine inverse function here we have the cosine function, right? But we need to have here a sine function, right? So the first objective is to convert this cosine function into this sine function, and then we have this angle that is theta, right? And here the condition is that this theta it must belong to this interval that is minus pi by 2 to pi by 2, and here theta is 39 pi over 5, right? And this angle does not fall in this interval, right? So we have to make use of some trigonometric identities so that this angle it falls into this interval, right? That is minus pi by 2 to pi by 2, including minus pi by 2 and pi by 2, right? So here the first trigonometric identity which we are going to use is to convert this cosine function into a sine function. So here we use this identity, that is cosine 2n pi minus theta is equal to cosine theta, right? And here n is some integer here. So if we split this angle, that is 39 pi over 5, as say here we have 8 pi minus pi over 5. So we'll express 39 pi over 5 as 8 pi minus pi over 5, because this is again equal to 39 pi over 5. That is 5 times 8 pi is 40 pi minus pi over 5, that is 40 pi minus pi is 39 pi over 5, which is same as this angle. So we can now write 39 pi over 5 as 8 pi minus pi over 6, and 8 pi can be written as 2 times 4 times pi, that is 2 times 4 is 8, and here we have pi over 5. So now here we have 39 pi over 5 in this form, that is 2n pi minus theta. So the value of n is 4 here, and theta is pi over 5. So now cos 39 pi over 5 can be written as cos 2 times 4 times pi minus pi over 5, that is 8 pi minus pi over 5. And using this identity, cos 2 and pi minus theta is cos theta. So here theta is pi over 5. So we have here cos pi over 5. So now we can write this expression, that is sine inverse cos 39 pi over 5 as sine inverse, and for cos 39 pi over 5 we can write here cos pi over 5. So now if we compare this expression with this one, here we have sine inverse, and still we are having here the cosine function, and here we have the sine function. So our aim is to convert this cosine function into sine function, and here theta is pi over 5. So now to convert this cosine function into sine function, we make use of this identity, that is sine pi by 2 minus theta is equal to cos theta. So if we take theta is equal to pi over 5, then we have sine pi by 2 minus pi over 5 is equal to cos pi over 5. So replacing cosine pi by 5 by sine pi by 2 minus pi by 5. So here we have sine inverse, and then we have sine pi by 2 minus pi over 5, right? So now if we solve pi by 2 minus pi by 5, then here we have the LCM as 10, and here we have 5 pi minus 2 pi, that is 3 pi over 10. So now we have here sine inverse and sine 3 pi by 10. So now if we compare this expression with this one, then here we have sine inverse, here also we have sine inverse, and here we have the sine function, here also we have the sine function, and theta is now 3 pi over 10. So theta is 3 pi over 10, and if we here write for pi as 180 degrees, because pi radians is equal to 180 degrees. So here we have 3 times 18 degrees, so this is 54 degrees. So theta, that is 3 pi by 10 or 54 degrees, it falls in this interval, that is 54 degrees. It belongs to the interval minus pi by 2 to pi by 2, which is our required condition. So now using this identity, we can now write the value of sine inverse sine 3 pi by 10 as 3 pi by 10, right? So the value of this expression is equal to 3 pi over 10, and we can see that 3 pi by 10 is equal to 54 degrees, and 54 degrees it falls in this interval.